Hello everyone and welcome to your 3.2 Ed Puzzle. Alright, let's go ahead and read the second paragraph. I think that's most relevant. It says, to begin, let's take a look at the most basic cubic function f of x equals x cubed. It's technically a degree 3 polynomial because the highest exponent is 3. That's important. The degree of a polynomial has to do with the highest power. So the highest power there is 3. But it's called a cubic function because these functions are often used to model volume. This is like quadratic functions, which are degree 2 polynomials, but they are quadratic after the Latin word for square. All right. So kind of the takeaway there is we're going to kind of explore what x cubed is, and it is known as a third degree polynomial. All right, so the first problem tells us, use a table to verify that f of x equals x cubed has a quadratic rate of change. I think they're saying a cubic rate of change, actually. It's interesting. This is from the company. I would say a cubic rate of change. It shouldn't have a quadratic because it's not a quadratic. All right, so let's go ahead and make a chart to see what rate of change x cubed has. All right, so remember yesterday we calculated, if it was a second difference, third difference, first common difference, or ratio. Let's go ahead and see what kind of a rate of change the cubic function has. So we've got -2, -1, 0, 1, 2, 3. Okay, these are the x values that I chose. I just chose x values that were close to 0. All right, so when you plug these into x cubed, all right, you get -8, -1, 0, 1, 8, and 27. Now notice how they kind of reflect like polynomials do, right? Polynomials kind of, when they're not transformed, they reflect over that vertex point. Here it reflects, but notice how the signs change, right? It's -8 and 8, -1 and 1. So they do have kind of they have a reflection, but the signs do change. All right, so now let's go ahead and find our difference here. So when we go -1 minus -8, we get +7. 0 minus -1, we get +1. Now, one thing I want to point out, make sure you're plugging these into your calculator properly. -1 minus -8. You need to make sure you plug it in that way. If you just do -1 minus 8, you're going to get the wrong answer. You have to do -1 minus -8. So be careful with that when you're trying to find the change. All right. 1 minus 0 gives us a +1. 8 minus 1 gives us a +7. And 27 minus 8 gives us a +19. All right, so that is our first difference. It's not a common difference, so we know that it is not linear, right? So now let's go ahead, find our second common difference. So you would do 1 minus 7, which is -6, 1 minus 1, which is 0, 7 minus 1, which is +6, and 19 minus 7, which is +12. So again, we do not have a common second difference either. So let's go ahead and try and find our third difference. All right, we're going to do 0 minus -6. We get +6, right? 6 minus 0, +6, and 12 minus 6, +6. All right, so that has a third common difference there. So we know that that is definitely cubic. All right, so now they want us to graph it. So we're just going to graph our original points here. So we've got -2, -8. Now, one thing, pay close attention to your y-axis here. Your y-axis is kind of wonky, so you definitely want to pay close attention to that. We get, oops, sorry. Put my 1s in the wrong spot. 8, and then 3, 27, so we'd be about here. All right, so this is our cubic function. All right, next it says, describe the features of x cubed, including intercepts, intervals of increase or decrease, domain, range, etc. Okay, so your intercepts, your x-intercept is 0, 0, right? If we look, x-intercept 0, 0. Same with your y-intercept. Your x-intercept and your y-intercept happen to be the same thing. Here, I should say, not all the time, but in this specific instance, they hit the x-intercept, right, and the y-intercept at the exact same spot. Then the intervals of increase or decrease. So this function is increasing on the interval 0 to positive infinity. Do you see how that function's increasing? So you would say increasing from 0 to infinity. Then we can see where it's decreasing. That's going to be from negative infinity to 0. Then we've got the domain and the range. So the domain, if we look, we can plug in any x value, right? You see how, the x values are continuing on this way, the x values are continuing on this way. There's no asymptote, nothing restricting the domain. You can even look at the function. You can plug any number into there, and you'll get a value out. So we would say our domain would be negative infinity to positive infinity. And then the range. So again, look at our x values. You see how it's going to increase into positive infinity and then decrease into negative infinity. So our range is going to be negative infinity to positive infinity. All right. All right. Next, it says, using your knowledge of transformations, graph each of the following without using technology. So first, let's kind of talk about the transformations we did with polynomials, right? Notice here how the transformation is outside of the x. Here it is inside, right? When it's outside of that x, that's going to have to do with the up and down. So that's going to shift your y values down by 3. That's what's going to happen there. It's going to shift all of your y values down by 3. All right. This guy is going to shift your x values down by 3. Okay. So this shifts the y values, right? That means it's going to shift up and down. This shifts the x values, and it does the opposite, right? So this is actually going to shift our x values in the negative direction by 3. All right. So let's see what happens here. So I'm going to go ahead and plot some points. Since I know it's just my y values getting changed, I'm going to take my numbers here and just shift my y values down by 3. All right. So I get -2, -1, 0, 1, 2, 3. All right. So if we look, we've got 8, -1, 0, 1, 8, and 2. We can go ahead and just shift those each down by 3. So we get -11, -4, -3, -2, 5, and then let's see, that was down by 3, so 24. All right. So these are our new values. All right. So we're gonna go ahead and plot them. So we get 0, -3. 1, let's see, kind of should be a little bit further, 1, -2, and then we've got -1, -4, so we'd be about here, -2, -11, and 2, 5. We'd be up here, and then 3, 24, which would be about here. So it's very subtle, but you can see that the intercept definitely shifted down, right? It didn't shift left and right at all. The x-intercept is still at 0, but your y-intercept now is at -3. So you can see that these y values compared to where we started, right? I guess I could copy paste these down there so you can see them. The y values each went down by 3. And we can double check this. Let's go to a graph and check and see how we did. So this is our original function. This is our x cubed. Now, this red one is the one that we just graphed. Now, keep in mind the scale is different here. Remember how I said the y scale is kind of wonky? But you can see here that it did shift down. All right. So you can definitely tell that we did we did a good job with this. You know, we needed our graph to shift down by 3, and that's what happened. All right. So now let's go ahead and try B. So we know that our x values are going to shift by 3. All right. So let's go ahead and make our new chart. So our y values are going to stay the same, which would be at -8, -1. Oops, sorry. Oopsies. 1 and 8. We can do 27. All right. Then we're going to shift all these down. So we're going to get -5, -4, -3, -2, -1, and 0. All right. So what I did is I just subtracted 3 from each of my x values. So now we could go ahead and plot. So we get -5, which isn't, oh, -5 is kind of far. All right. So -5 would go here. All right. And we've got -4, -1. And then -3, 0, -2, 1, -1, 8, and 0, 27. Oops, it should be down here. So you can tell here that the graph shifted, right? And let's go ahead and check. I'm going to plot, we have our original function. This is our new one. Do you see how it shifted to the left by 3, right? We subtracted 3 from the x values. All right, so now let's go ahead, try the next one here. So what does putting a 2 out in front do? Well, this multiplies the y values by 2. All right, so what you're going to do is you're going to keep your same x values. So we have -2, -1, 0, 1, 2. And we're going to multiply the y values by 2. So we get -16, -2, 0, 2, and 16. How did I get these? I just took my original ones and multiplied them by 2. All right, so now let's go ahead and plot them. We get 0, 0, -1, comma 2. I'm sorry, -1, comma -2. 1, comma 2, and then 2, comma 16, and -2, -16. All right, so we get something that looks like that. Which you probably can't tell a huge difference, I feel like, on this scale, but we'll go ahead and look. All right, you can tell that the green one, which is the new one, is growing faster. All right, that's what it does. When it doubles the y values, that just means it's growing like twice as fast. All right, and you could tell that that green one definitely grows faster. All right, so I got our last one. So this one has multiple changes going on here. All right, and let's kind of talk about what those are. So this one still shifts it to, this one's going to shift it to the right one. This is going to shift it up. And then this reflects it. Okay, that reflects it over the x-axis there. All right, so I will say this one is quite tricky. And pretty much how I would approach this is to take your original points and kind of do these transformations on them. So we're just going to do like 1 or 2 points because it does take a while. So like if we had the point 0, 0, 0, we're going to shift it to the right 1 and up 2, right 1, up 2. Okay. Oh, and actually you should do your reflection first. But this one we can't reflect because it's 0, 0. So our new point would be there. Let's go ahead and plot another point. So we'll do, let's do 2, 8. All right, so we started off at 2, comma 8. We need to reflect over the axis, so we would go there. And then we're going to go ahead and shift it 1 up, or 1 to the right, and 2 up, which is kind of tricky. So we get something like this. Also, my red one should have been about here. All right. So as you can tell, this does get a little bit tricky. So let's go ahead. We're going to try using Desmos. So let's go ahead. Oops. All right. So I want to point out, look, you can tell that it got shifted, right? If we look at this point, we went one right, two up. And then we could see that there was a reflection, right? It reflected over the x-axis. So what we can do here is we can even just go ahead, make a table. All right. So we've got -2 to 2, and I'll go ahead and write out the chart. All right. So now we've got 0, 3, 1, 2, 2, 1, and 3, -6, and -110, and -2, 29. All right, so you can see that transformation. All right, so now for number 6, it says, since quartic functions and cubic functions are both in the polynomial family of functions, we would expect them to share some common characteristics. Looks all the similarities between x cubed and x squared. So just to reiterate, x cubed we graphed looked like this, and x squared looks like this, right? So one thing that they have in common is they both have the same x and y intercept when not transformed. All right. Then they also both have the same domain, which is -infinity to +infinity. All right. All right. So let's go ahead and try this last one now. Your notes probably do not have this in there, but I want you to pay attention to how to do these because you have ones that are similar to this in your Ready, Set, Go. So pay attention to this so you know how to do your Ready, Set, Go. So basically they want us to graph f of x plus g of x. So what that means is at the different points, you have to find the y values and add them together. All right. So let's go ahead. Both of these graphs are at 2, right? So f of x is 2. G of x is 2, so we're going to add those up, and we'll do it in green. We get 4. So that would be our new point there. All right. Then for 1, we've got 5. We've got 3, so our new point is going to be 8. All right. And then we could do -1. So we've got, oops. Sorry, should have went red first. We've got -1, and we've got 1. So our green guy is going to end up at 0. All right. So basically, all you do is take the y values, add them up, and you get your new line. Next one, we got f of x minus g of x. All right. So again, we'll find our f of x. Oops. So our f of x here is 2. Our g of x here is 2. So when we subtract those, we're going to get 0. All right. Next one. Our f of x is 5. Our g of x is 3. You subtract that, and you get 2. All right. Let's do another one. Our f of x is 8. Our g of x is 4. We're going to get, oops, for our new line, we get 4. All right. And then here we could do 1 in the negative. So here, our f of x is -1. Our g of x is 1. All right. And we would end up with a -1, -1, we end up with -2, right? So we were kind of off the graph a little bit there for our, for our green. But it's going to look like that. All right. So basically, when they're asking for something like this, you're just taking the y values, adding or subtracting them.